Hi, today we're going to continue with our previous tutorial, which is the left mechanism. What we're going to do today is to assign some constraints and joints, motions, to perform our simulations. So, as we've already built our model, there's no need to build any model. You just go to the existing model and import the existing model, and then work on from there. So, under file name, going to locate where we saved our model. See, so you click on this icon there, and you can locate the model, which is our left mechanism. .bin, that's the extension for Adams. Click on it and open. Now you can see that the directory and the file name has been inserted. So we click on OK to import the model in Adams. Okay, now we can see that our model has been imported in Adams. Let me try to change the orientation of this. Okay. Yeah, good. So for us to work better with the models, the geometry that has been created, we're going to change it from the solid view to a wireframe. Okay. So our first step is to create a constraint. Our first step is to constrain the base. Is to constrain the base to the ground to create a fixed joint for the base. So we come to connectors, locate fixed joint, which is this. So another fixed joint construction, make sure that two body one location is selected, normal to grade selected, first and second, peak body selected for both. So our first step is to select the first body, which is our base, our second body, which is the ground, and then select our location, which is the midpoint of the base, where we're going to put the fixed joint, which is here, has been selected. We cannot see the joint created. What we can do is try to increase the appearance of the joint. So you right click on the joint you just created, you go to joint, then select appearance. There's a box opens where you can specify the dimension for the appearance. Let's say 1 apply. Okay, now we can see the fixed joint, which is like the padlock here. Now that we've created our fixed joint, our next step is to constrain the mount, which is the green part, to the base, the red part here. So we're going to do this by creating a revolute joint. Come to the connector, locate revolute joint, which is that. Going to select the first body, which is the mount, the second body, which is the base. Now that our body has been selected, you have to select the location, which is the midpoint of the mount. Select it. Okay. So we go again. There's a power. Everything is. Oh, sorry. So under the construction, instead of maintaining the normal grid, we change it to pick geometry so that we can pick different features. So we go again, select the first body, the mount as the first body, the green part, and the base, second body. Then select location as a midpoint for the mount. Now we can choose After selecting the direction, after selecting the location, now we have to select the direction vector, which is our global y direction. So we have to select our direction vector, which is in a global y direction. Yeah, this is our global y direction. So select it. Now, our revolute joint has been created. As we can now see, you have to increase the appearance. So right click, go to joint, appearance, then set dimension for the appearance, just 1.8, apply. Okay, now you can see that our revolute joint has been created between the mount and the base. Now, our next step is to constrain the shoulder, which is this yellow part here, to our mount, the green part. So hide, we can hide our second joint, which is our revolute joint. Can hide it, right click on it. This menu opens and go to hide. So it'll be easier for us to create the revolute joint between the shoulder and the mount. Go to revolute joint. You make sure that two body and one location is selected. Then instead of pick geometry feature, select normal to grid feature. Now that we have all these set up, we're going to select our bodies. Our first body that we're going to select is the shoulder, which is part 4. And our second body is the mount. Now we have to select our location. To select our location. So our location is going to be the midpoint of our amount. Our location has been selected. Our revolute joint has been created. So we cannot see, we have to increase the appearance of that. So we right click on the joint you just created, go to joint, appearance, let's set the dimension to 1.8. Sorry. Apply, okay. Okay, okay, let's go to the structure tree here and try to change the parent from there. 1, 2, 4. All right. I think the first one we did not select the beverly joint properly. That was probably why it did not affect the appearance. So now that we have our second beverly joint created between the shoulder and the mount, we can now unhide the second joint, right click on it and go to show. Now we have our two revolute joint and our face joint. We've created two. Sorry, created two. We've created 3 joints already. Our next step is to constrain this boom to our shoulder. So we're going to create a translation joint between the boom and on the shoulder. You go to connectors, locate a translation joint, click on it, make sure that it is set to two body one location, pick geometry features. Then first and second is pick body. So first thing we're going to do is to select our bodies. First body is our boom, which is the blue part here. Select the boom. Our second body is the shoulder. We select the shoulder. Then we're going to select the midpoint of the boom as the location. So we have selected the midpoint of the boom as a location. Now we have to set the direction vector. And we want to set a direction in the global X direction as the axis of rotation. Is this cm.z. That is our global X as the axis of our rotation. Click. Now our translation joint has been created. If you can select it here, you can come to the structure tree and the connectors, our joint 4, and then increase the appearance of our translational joint. So you right click on joint 4, come to appearance, then set appearance to 1, apply. Okay. Now our translational joint is visible, has been created. Our last joint that we have to create is a revolute joint between our bucket and our boom. So you go to the revolute joint, make sure that under construction is set to two body one location, normal to grid. And now we come to the working grid to select the bodies. So I have select the bucket as the first body, select the boom as the second body, then you select the point here, the point here of the boom, that's the center. For the direction, sorry, for the location. Now our revolute joint has been created between the bucket and the boom. Come to joint 5, change appearance, right click, and then appearance, 1 inch, apply. Okay. Now, so now all our joints has been created for our model. Our next step is to try and verify to make sure that everything is in place, everything is working. Everything is working. So we come to the right hand bottom corner here, the information icon, right click on it, and then click on this verify. Now you can see that it says here that the model verified successfully. It means that everything is working perfectly. You can close it. And now we're going to add joint motions to our joints that we just created. So first, we're going to add a joint motion to, sorry, we're going to add a joint motion to the mount to the mount to base. The mount to base joint, which is our second joint. The mount to base joint, which is our second joint. So we go to motions here. Our mount to base joint is a revolute joint. So if you're going to create a motion, it has to be a rotational joint motion. Select the rotational joint motion. And we have this. So under the rotational speed for our rotational joint motion, we input 360 d times time, 360d times time. Three 60d times time, and then select and then select our mount to base revolute joint to apply. I've selected it, so that means I've applied the motion to our second joint, which is the mount to base joint. The next step is to apply the same rotational motion to our shoulder to mount revolute joint. So here we can hide this joint again for easy access to the third joint, which is our shoulder to mount revolute joint. We're going to create a motion, we're going to add motion to that joint. So click on, we select rotational joint motion, rotational joint motion. Joint motion, we select our joint 3 to apply the motion to it, but we maintain the default speed for now. It has been applied. So motion has been applied to our third joint, third revolute joint. So after that, because we use the default rotational speed, we're going to input our own speed into it. So we go to the third joint, right click on the third joint. Sorry. We go to the structure tree, sorry. Go to the structure tree and the motions. So our second motion, which is for our joint 3, right click on that motion, that joint motion for our joint 3, which is the shoulder to the mount in the model tree, and click on modify. Yeah, this box open for the joint motion modify. So under modify, we have function, which is time. This is where we're going to input our own speed. With our own speed, we have step bracket time 0, 0, 0.10 from 30D bracket close. Okay, so this is a new function for our new function for our shoulder to mount bevel joint. Click on apply. And okay. Now we bring back we on hide our joint two. Now we're going to apply a motion joint to our translational joint. Which is this one, which is the boom to shoulder joint. So the fourth joint according to our screen. So we click, because this is a translational joint, we're going to perform a translational motion. So we select a translational joint motion. You have that. We maintain the default speed for now. So now that we click translational joint motion, we have to select. You have to select our translational motion to apply it. So we have applied the translation joint motion to our translation motion, which is joint 4. We go to the module tree and then under motions, right click on the translational joint motion we just created. Click on it, go to modify. Now on the function, we can change our new speed, which is step bracket time 0.8, come on, 0.15. So our new function has been set. Click on apply. Okay. Now we created our translational motion for our translational joint. Our last joint, which is the joint between the boom and the bucket. So we're going to create a revolute motion joint. For that, we go to, so under motion, we go to rotational joint motion. Click on that. We select, we maintain the default speed, select our fifth joint, which is the joint between the bucket and the boom, to apply the rotational joint motion. Now that is applied, we go to our structure tree under motion, just motion 4. Right click on it, go to modify. Modify. Under function, we input 45D great 1 minus cosine 360 D times time bracket close. Yeah, we'll set a new function to our new beverly joint motion, which is our joint 5. Apply. Okay. Now we have set a joint motion to all our joints that we created. The next step is to verify the joint motions to make sure that they are all properly entered or properly assigned. And if not, see how we can correct it. So we do that by first going to each joint, going to each joint, right clicking on them, and going to modify. Okay, going to each joint, except to the fifth joint, because it's not assigned any motion to it. So for the second joint, which is the joint between the mount and the base, right click on it, modify. Then under the modify joint, we go to impose motions. The import motion, we can see that the function is not the same as the one we assigned. It's supposed to be 360D, 360D times time. So if not, we just change it and then reapply it again and okay. That is for our joint 2. To check our joint 3, modify impose motion. Our joint 3 is right. Okay. Go to joint 4, impose motion to verify it. Looks like everything is right. 2, joint 5, impose motion. Looks like everything is right. So you come to the motions created, go to modify. Yes. Modify. Yes, we have the same. Yes, we have the same. Okay, we have the same. So it looks like everything is in place, has been verified, or have the same speed. We have the same speed for all the joints and the joint motions. Now that our model has been verified, we can go on and simulate the model. We're going to simulate the model for 5 seconds. So we come to the simulation and here go to interactive simulation. Click on that. And now we have our simulation box. So in our simulation box, we will make sure that end time is 5 seconds and our steps, 500 steps. So like we said before, running, and then run. Now we can see that our simulation is functioning the way it's supposed to. Functioning the way it's supposed to. So now let's rerun it. All right, thank you. So we have been able to assign the joint the constraints to our lift mechanism, and it's simulating according to our